Hello everyone. Today, instead of memorizing root cause analysis tools, let's solve a real problem together. Imagine you're the quality manager of a factory producing 10,000 water bottles every day. Normally, the defect rate is 1%, which means about 100 defective bottles daily. Suddenly, customer complaints increase. The defect rate jumps from 1% to 8%. Now the factory has 800 defective bottles every day. That's 700 additional defects. If each defect costs $2 in scrap, rework, returns, and customer service, the factory is losing about $1,400 every day. That's more than $42,000 every month. Management wants answers. Production blames the machine. Maintenance blames the operators. Operators blame the supplier. Everyone has an opinion, but nobody has evidence. That's where root cause analysis begins. First, let's define the problem. Leakage defects increased from 1% to 8% during the last month, creating 700 additional defective bottles per day. Now we need to find where to focus. Let's start with Pareto analysis. The quality team reviews the data. Out of 800 defective bottles, 480 have loose caps, 160 have damaged threads, 96 have cracks, 64 have labeling defects. Loose caps alone account for 60% of all defects. So instead of chasing every issue, we focus on the biggest one. Loose caps. Now we know what the biggest problem is. But where is it happening? Let's use process mapping. The process is simple. Bottle molding, cooling, inspection, cap placement, cap tightening, leak testing, packaging, shipping. At which step can a loose cap occur? Cap tightening. Immediately, we've narrowed our investigation to one part of the process. Now we know where the problem occurs, but we still don't know why. Let's use a fishbone diagram. Possible causes include people, operator training issues, machine, a worn capping head, method, poor setup procedures, material, cap quality variation, measurement, an inaccurate torque gauge, environment, temperature changes. At this point, we have several suspects, but we need evidence. So the team collects data. The required cap torque is between 18 and 22 units. Actual measurements on leaking bottles are 11, 12, 13, 14. Every reading is below specification. Now we have evidence. The leakage problem is linked to insufficient tightening force. But what's causing the low torque? Let's apply the 5 whys. Why are bottles leaking? Because the caps are loose. Why are the caps loose? Because insufficient torque is being applied. Why is insufficient torque being applied? Because the machine is operating below the required setting. Why is the setting incorrect? Because the machine was recalibrated incorrectly. Why was it recalibrated incorrectly? Because there is no standardized calibration procedure. There it is. The root cause. Not the machine. Not the operator. The absence of a standard process. Now let's evaluate the risk using FMEA. Failure mode, loose cap. Severity, 9. Occurrence, 8. Detection, 5. The risk priority number is 360. That's a high-risk issue requiring immediate action. Let's summarize the investigation. Pareto analysis helped identify the biggest problem. Process mapping showed where it occurred. The fishbone diagram identified possible causes. Data collection provided evidence. The 5 whys uncovered the root cause. And FMEA helped prioritize action. The immediate cause was loose caps. The contributing cause was incorrect machine calibration. The true root cause was the absence of a standardized calibration procedure. To fix the issue, the company introduced a calibration SOP, trained maintenance staff, added setup verification checks, and monitored torque regularly. Within 3 months, the defect rate dropped from 8% back to 1%. Customer complaints decreased. Operational losses were eliminated. The key lesson is simple. Root cause analysis is not about finding who made the mistake. It's about finding what allowed the mistake to happen. If you found this case study useful, please like the video. For more content on process excellence, Lean Six Sigma, quality management, operational excellence, and continuous improvement. Subscribe to Process Excellence Hub.